N. Thank you for reminding me. I'm not surprised. I forgot that. Just trying to stay connected. What is p hat? Anybody? Anybody tell me what p hat is?
Number of successes?
No. Because why is it the letter P for one thing? Why is it the letter P? Huh?
Never mind. I don't know.
Proportion of success?
Yeah, proportion or percentage, right? So it's a percentage. It's the percentage, it's the probability even of success. Is that okay? Are you guys? So in this case, what would the probability of success be?
65%.
Good. So that's the number. Now to answer number 75, you just have to tell me in words. And I don't mean write the number 65 in words. I mean what it represents. Right? Okay. Like the symbol X bar represents the sample mean, correct?
Random variable X is, okay, I can't ask you every question in the homework, so I'll stop.
So X is always the X is the number of successes. P hat is the sample percentage of successes.
So X is just the number of voters.
No, N is the number of people they talk to. They talk to 1,200 voters, right? Right? 1,200 voters, right?
Yeah.
Okay. If 600 of the voters said the economy, then P hat would have been 50%. Do you see what I'm saying? What could change? The variable.
So random variable X is 65% of 12.
Okay, sure. It's whatever 65% is for a number. Number 74 doesn't give a shit about the number. It just wants to know what is it in words. I don't care about the number. Right, so it'd be the number of people who said the economy because it's the number of successes. Are you guys with me out there? I think what trips you guys up is when they give me the percentage, I don't have to do work to find it because they just gave it to me, right? So normally I like to give you problems where I say 7 people out of 30 said this, and then you have to do 7 divided by 30 to figure out the percentage. But the book likes to sometimes give you the percentage. Okay. Oh, I see what's going on.
So X and P hat are the same thing in this problem.
Never, ever, ever. X, listen.
Okay.
X is a number of things. P is a percentage of those things.
Understood.
That's why we give it the letter P, really. And then we're like, well, we have another percentage. We can't use P again. And then we thought, what's the next letter? Oh, Q. All right, there you go. So we made P's and Q's. That's the drunk history of mathematics, right? I should make the drunk history of mathematics series.
I would like to see that, actually. I think you'd be pretty funny.
That. I have. Why not? Another reason to drink. I like it. Why is the rum always gone? Because Jeff made those stupid videos. They ain't coming.
Drunk History is one of my favorite shows.
Definitely. All right, guys. Anything else? Again, please hear me. Even if I just explain something and it doesn't make sense still, you can ask me to explain it a different way. That's fine. Right? That's fine. Is everything else okay? All the homework is okay so far? Everybody understand that if you're not going to be able to finish up chapter 8, the most important thing is to get enough practice to be ready for the quiz tomorrow, right? That is the most important thing. Katrina, do you have a question?
Yeah, it's for some old homework corrections. I'm just starting to review for the final. I'm going back through everything, so I'll ask later. So because it's kind of getting late.
Gotcha. All right. We could do that after class. If nobody else has any more questions, I gotta remember where we left off. I'm still a little bit discombobulated from the pathetic connection I had earlier. Where can we post redo assignment? If you're correcting homework, you put it in the exact same place you first submitted it. You submit it right on top of the old submission. Does that make sense? And the same thing for quizzes. Right? Sure. Okay. I think last time, did we finish that sheet we were looking at? Let me see. I don't think we quite did we? Let's take a look here. Let's remember what the hell we did. Here we go. So we did this forward focus problem, and it looks like we did finish it. We did the forward focus problem, and we did the credit debt problem. You guys remember that? If somebody will remind me, I could post this answer sheet, right? Okay, so what are we going to do today? First thing I'm going to do is I'm going to turn off the moon. That's no moon. It is the moon. Oh, shit. You're right. If it will let me, there we go. Oh, sorry. All right. So, so we've got hypothesis tests for a mean. Now, some of you guys, I've already started like section 9.5, which kicks ass. But we still haven't talked about hypothesis tests for a percentage. So I could have a claim like I claim that more than 30% of Grossmont students take statistics. And that's a claim about a percentage. So the method we have for testing means won't work. It's not going to be the same thing. All right, so the first thing we got to do. So I want to talk about two things today primarily. Hypothesis tests for percentages and then types of error. That's the two main things that we have to do. And then we'll see how much time we got left. Let me see. How's my lighting look? I guess it look okay. Weird lights turn on. Let's do this. There we go, it's a little better. Get some glare out of it. Okay, now. So let me point something out to you guys. I'm gonna do this in what seems like a weird way. And to be completely honest, just to let you into my teaching method, I just thought of this way right now as I was talking to you. Do you guys remember this formula here? Hopefully so. What part of this is the standard deviation for this situation? What part of this is the standard deviation?
The standard deviation divided by square root of n.
Yeah, this piece, is that cool? The piece that is sitting next to the z is the spread for this situation, right? And I'm saying this in a weird way maybe, but you're like, that's the new standard deviation, Jeff, yes, right? And so in a hypothesis test.
Real quick, what does the formula, there's no equals, so it's just x bar plus minus z. So what is that actually trying to find?
What does this create for? So this is a weird, real quick, before anybody answers. I love that you just said that. This is kind of a strange thing. We're not used to having some mathematical statement without an equal sign. What does this thing create? This is more of a creation thing.
Your interval or your range, like the stuff, the two x's you're in between.
Sure. And what's that thing called?
Error
The range or the interval.
Confidence interval.
There we go.
Confidence interval. So there's three formulas that look like this, right? There's this one, there's the T and the S, and then there's this one. Right? Still a little bit bright. This is weird. Sorry, guys. What is happening?
And the n that's included within the square root, right? For the formula, p hat, q hat over n, that everything is under the square root, not just the
Yeah,
top.
I like it. I like it. Now, stay with me. Stay with me. This is kind of old news, though. We knew about this before we talked about confidence intervals, correct?
Mhm.
But I'm doing it this way for a reason. When I'm doing a hypothesis test for the mean, don't I at one point do this? You know, this we normally do on the side, but do you agree with me? We put the new standard deviation down here. Is that cool? So this is the spread for means. So of course I would use it here because the z-score is this difference divided by the spread, correct? Are you guys kind of with me? I know I'm saying things a little bit weird, but I'm doing that for a reason. Okay, now, if I have a hypothesis test for a percentage, so look here, isn't this, what is this here?
The sample mean?
Sample mean, so it's like our data. So when we go to do a hypothesis test, then we take a sample. So our data would be the sample mean, and then we compare that to the supposed mean. Is that cool so far? The mean from the claim, right? We want to see how far apart those are to see if I got something really freaky or not. So does this make sense? The formula for the z-star for a percentage hypothesis test. What is the percentage we get from the sample? What symbol do we use for that? The percentage that we get from the sample. I've actually got it up here somewhere. The percentage from a sample. What symbol do we use for that?
P hat.
P hat, I love it. What symbol do we use for the percentage from a population? Let's see if somebody remembers. This is nothing amazing. In fact, we didn't even have a hat on that thing before because we were always talking about a population percentage. So sample mean minus supposed population mean. Sample percentage minus supposed population percentage. So it's just a P that lost its hat. That's the population percentage. I have no idea if you guys are with me so far. I really want this to make sense. What's the fundamental good Lord, Jeff. Do I need more of this? All right, let's try this again. What is the fundamental idea of a z-star? Is how far did my sample data get population mean that we're assuming? How far did my sample data get from the pop? Right, so it's the same. Oh crap! It's saying I'm unstable. How am I doing?
You're good.
still
now.
here?
You kind of cut out for a second for me, but you're good.
Okay. All right. I appreciate those of you with cameras on because when everybody stops moving, then I know it's me. All right. Don't you all get together and go? All right. So now look. This was the spread because it's in the right place, and that's what we use here. So what am I going to use here? What's the right spread? Because they're not going to give you a standard deviation for percentages. They never do. What's the spread that what's the spread from that formula up there that we used before? What's the
root?
Yeah.
U hat Q hat over N.
Isn't this in the same place?
Mm-hmm.
Isn't it supposed to be the middle, give or take, the number of standard deviations times how big each standard deviation? So this must be the spread. So sure enough, that's what goes down here now. All right, sorry. You ready? I don't know how to say this right now. In a hypothesis test, we assume that this is true. Don't we in a hypothesis test, we go, okay, assuming that the claim number is right, look at the weird shit we just did. That's basically the idea. So since we're assuming this is right, I don't have to use sample, I can just go ahead and use P. Get out of there, Jeff. You just like drawing little hats on there. I can just use PQ. I can just use the population numbers. Yes, William. Z star is the relative distance, of course, in standard deviations, that the sample data got away from the mean. That's what Z means, always. How many standard deviations did our sample get from the supposed middle?
Could you say again why you used P and Q instead of P hat, Q hat?
Because all right, when do I have to use S? For example, what is it?
Sample standard deviation?
When do I have to use that? When should I not use it?
Well, have the regular.
Yeah, because S approximates sigma. S
Okay.
is like my best guess for when I don't know sigma. So remember that one problem they gave you both?
Mhm.
Like, why would you ever use S if you have sigma? S is just a poor stand-in for sigma. So of course, no. So here, I only use P hat and Q hat when I don't know P and Q. But what am I doing in a hypothesis test? We're assuming that this is the real percentage. I really want you guys to get that, right? We're assuming. So if the claim is, oh, I think 50% of people like P's, we're like, I think you're wrong. We'll go, we're assuming you're right, assuming P really is 0.5. So then we can use P and Q. We know what they are. We don't have to use the hatted ones. I know that feels weird, but that's how hypothesis. Have you ever heard of proof by contradiction? I don't know if you've ever heard that.
Maybe.
Have you ever heard somebody say, assuming that you're right, look at that weird shit. So like you're looking at somebody, they're saying, everybody who gets the COVID vaccine gets sick, right? You're looking at this person, that's what they say. And then you go, assuming you're right, you just got the COVID vaccine, right? How are you feeling? I'm feeling fine. Oh, okay. All right. Right. You guys, so assuming you're right, look at this weird thing I just saw that goes against what you just said. So that's what we're doing with the hypothesis test. Assuming the number from the claim is right, we're going to check to see, look what we just did. Was it weird? Assuming this is right? Was this weird? Assuming this, so we're assuming this is right, so I can use it. I don't have to use the hatted ones because we're assuming we know what the real P and Q are. Maybe. So let's go ahead.
Could you show us a problem?
That's
using
exactly
that
the
one?
next step, obviously, now is to stop just talking about what would happen and actually do it, right? It's always a good thing. Just to answer Billy's question, what does Q mean? Anybody?
The probability it wasn't successful.
Yeah, probably failure. Right. So if it's 65% like P's, then 35% don't. That's P and Q. All right. So let's do an example. Do I have a worksheet? I think I do. Okay. Let's see. Bum, bum. All right. There we go. Still have old stuff here. All right, hold on. There we go. Let's see if I've got. Here we go. Yeah, I do. Yay! Incredibly enough, the sheet I'm going to use is called Hypothesis Practice Percentages. Right, so that's like, good job, Past Jeff. All right, so there we go. So we're talking about Chicago police, and we're talking about taking a 4-week stats course. Dude. All right, so let me open this a different way. There we go. Cool. Everything, it takes so long. All right, here we go. All right, let's take a look at this. So we're going to do one of these together, and then I'll let you guys do the other one. So let's do this Chicago one. Chicago. So Chicago policeman claims that at most 55% of Chicago residents have an unfavorable view of their local police. And then they take a sample of your shit. So what's the claim that's being made?
That at most 55% of Chicago residents.
Good, good. So
Have an
now
unfavorable.
condense that into beautiful math.
So the mean is less
Careful.
than or greater,
Careful.
or the percentage is less than or equal to 55 or 0.55.
Look at that kick-ass stuff happening. All right. Nothing wrong with getting it wrong and then immediately correcting yourself. That's beautiful. Does everybody else see how that came about? The biggest mistake I see is people keep it as 55, but that's not what 55% means, right? Now, humans invented every number there is. We did. We just invented all the symbols, but we extra invented percentages. Math needs the actual number, which is always the decimal. Okay. So now watch. Now listen. I am all too well aware that we haven't exactly done like a ton of hypothesis problems and stuff. Still kind of new to you guys, but this should feel very familiar related to some of the ones we've already done. We've written the claim down. Where am I going to put that claim? Which spot does it go in? Let me change this to ha. Which spot does it go in?
Oh,
What'd you call me? Oh yeah, no, it goes in here. I like it. And then, is everybody cool with that? Because of course it has an equal sign. So I really want you to understand there's only two major differences if it's a percentage instead of a mean. We see one of them up here. The formula changes, right? Of course it does, because I need percentages in them. And the way that we tell if it's normal changes, right? Otherwise, everything's exactly the freaking same. So what am I going to put next to the ha?
P is greater than 0.55.
Crazy. So how many tail tests will this be?
1.
One tail. And can somebody else tell me where that's going to be? Where is that tail?
On the right.
Good. It's going to be up here because it says greater than. Although I've written that horribly and I can't stop eating that. Okay, Jim. We'll do that. That's better. I like it. All right.
Would it be drawn that far up for the 0.55? Because it's only 4.5 that's greater than that, right?
I'm sorry.
0.45%.
I need you to understand that this picture is like z-score stuff. So this would be 0.55 in the middle.
Oh, okay. Not just like 50%.
Yeah, so 0.55 is the middle number. It's sort of like a mean in that respect, but it's the expected percentage if 55 is the correct percentage. Are you guys semi with me? So this distribution is if I took a lot of samples of Chicago residents, like if I took one sample of 996 and another sample of 999 and another sample of 999 and another sample, and then I plotted all the percentages of those samples, the most likely percentage would be 55, and then it goes down from there both ways. Now we actually haven't proven yet that it's normal. We're about to, but why is this distribution normal enough? What do I have to check?
And NP and NQ.
Good. So what's N?
594.
Careful. I heard the right answer and the wrong answer. So N is 996. N is always the total number. 594 is just the number of successes, right?
Oh, okay.
And I'll see if somebody can tell me the right answer for this. What's P? There should be no work for this. To give you a hint.
55.
55, exactly. It's 0.55. So what's Q then?
0.45.
4, 5. Let me stop for a minute. You have got to speak up. What happened so far that doesn't make sense?
Yeah, I'm still blanking on how come you drew the line so far up and not right where the 0.55 is if you're trying to find everything greater than 0.55.
I'm not trying to find everything greater. I'm not. Here,
Trying to disprove.
hold on. Let's go back here. All right, look here. Mu less than 906, right? Where is 906 in that picture? Where's 906? Isn't it the mean?
Yeah,
Wouldn't it be here?
right.
So it's
Can't
not
do anything outside of it.
it's not the probability that something is less than 906. That is not what that is a claim, not a probability question. It's saying we're claiming this. And remember what's got to be true. Not just the sample is 905 or something. I mean, that's less than 906. It's got to be freaking less enough. It's got to be far away enough to show evidence that it's not 906. If I got 905, that is technically less than 906, but that is definitely not different enough. Couldn't that just happen by random fluctuations, right? If you flipped a coin 20 times and you got 11 heads, are you going to be like, what the shit? You should have been 10. You got it. What? No, who cares? That's random fluctuations, correct? I really want this. All right. Does that make sense, Katrina? Okay. So it's not a probability question, it's a claim. And the idea is to show evidence for that claim, we have to have a sample that is into unusual territory. And isn't unusual territory defined to be kind of far away? So that's why I drew it way up here. That's like my representation at the moment of where unusual starts.
Okay, I good. I saw the P, my brain went to probability because I'm still like in chapter 7 mode after the quiz
blame you.
yesterday.
I don't blame you. It's okay. All right. So what are these? When you multiply these, what do you get? That's 540 something. Is that right?
547.8.
And that's at least 5. And of course, this will be 448.2.
Mm-hmm.
Ah, look at Jeff doing math. All right. How you guys feeling? So that takes the place of n greater than 30. Now, all right. Now watch this. You're gonna love this. You're gonna love this. You got it. Can you guys, real quick? I should have pointed this out earlier. How many formulas do we have for confidence intervals? There's one more I left off up here, right? Does somebody remember? I've got the. Let me stop sharing for a second. All right. Isn't there 3 total? So there's x bar plus or minus z sigma. There's the p hat one. What's the one I'm missing?
The T.
And what's that one's go? Give me the full thing.
Is it the sample mean plus or minus T?
And remember, I told you this is a little clue. When do I use a t-score? When I don't know sigma, right? How many formulas do we have for p? 1. So what I want you to realize is t-scores were invented for when I'm talking about means and I don't know the population standard deviation. So when I've got hypothesis tests for percentages, I either use z-scores or I don't do anything. I never have to use t-scores in this situation. And I need you to realize the fact that there are 2 formulas for the mean. Jeff, there it is. 2 formulas for the mean and only 1 for the percentage is kind of a clue. Oh, sweet. So see how I asked this question? Look, I'm trying to be nice. I really am. And I'm new at it. So I'm sorry if I don't quite do it well. But notice how I asked this question. Is the distribution normal? I don't say Z or T. That would be really evil, right? So just say, is it normal enough? If it is, we use z-scores. If it ain't, we don't do anything. So is this normal enough?
Yes.
Yes. So that means we can do it, which means we use z-scores. So if either one of these was not at least 5, we couldn't do anything. We just say, can't do it, go to the next problem. Okay. Let me say this, because this does get, I will never put a problem on a quiz or a test where I purposefully make it so that if you pay attention, you don't have to do it. Does that make sense? It would be so mean for me to give a problem where I'm like, you're like, that took way too much time. I'm like, you didn't notice, you didn't have to do that one, you spent time. No, so if you think that you don't have to do it, you should still do it, because more than likely you missed something. Does that make sense? In general, in the real world, if you got one where it was less than 5, one of these two, NP and Q, you ain't got to do it. You can't do it, actually. Not just you ain't got to do it, but you can't do it unless you know some stuff that we would teach in Stats 2 if we had a Stats 2. There's actually something you can do, but before.
Hey, Jeff.
Sorry, go ahead.
So what does 547.8 and 448.2 mean? Like, does that mean, I don't know what that means.
Well, you know what 547.8 is, because you remember what n times p gives you, maybe. What's that the formula for?
For probability of
No,
success.
that's what p is. But what is n times p? Anybody remember? That was a beautiful little formula. N times p. What does that give you?
You?
It gives you the mean. The mean number of successes. So this is the mean number of successes, and so that must be the mean number of
Fails.
failures. And please remember, oh my goodness, I know it feels like you got all this stuff to memorize and shit, but it's a question of what things do I remember to make things make more sense. Do you remember this whole discussion about if the mean was too little, there's not enough room for it to look normal? Do you guys remember that discussion at all? If the mean was at least 5, then there's room for it to grow and there's room for it to shrink. So it looks normal. If the mean is too small, or if the mean is too big, which is kind of like what that guy does, then there's not enough room for it to go up and come back down. Does that make any sense to anybody? Do you guys remember that? No? Oh, you guys are all like, damn it, why couldn't his internet just have stayed out? And he sent us a message saying, no class today. You're all like, man, this sucks. We had a chance. All right, whoever bribed Cox, you didn't give him enough money. All right, now let me say this one more time. Does anybody, and it's okay if the answer is no, does anyone remember this discussion I had about if the mean was like 0.1, could this ever be normal? That has no chance to be normal, right? If the tallest peak is at the edge, where's the tallest peak supposed to be if it's going to have a chance to be normal?
In the middle.
Somewhere in the middle. So we've determined that 5, if the mean is at 5, that gives it room to grow and to shrink so that it looks normal enough. Maybe that's really all that check does. That actually makes more sense than n greater than 30, but you don't quite agree with me just because you've known n greater than 30 for longer. But this actually, you can kind of visualize why that makes some kind of sense. All right, maybe. Okay.
So B, would you accept the answer yes because yes because the number is greater than 5, or would we have to expand upon that to get full credit?
If you gave me this, which is exactly what we've done, this is beautiful. This is it. You did the check and you said yes. I mean, and you answered the question, right?
Okay, thank you.
You're welcome. Bless you. So the part B is different. but it's not that different. We've seen this before. Part C is the same. Part C is the same. How many tail test was this? So this is a one tail test, right? Alpha is 0.00. Uh-oh, is this where I was evil? This might be where I was evil. Yeah, this is where I was evil. That's right. You know I had to be evil somewhere. Let's see if anybody gets this. Can you use your T-score chart for this?
Yes.
I think you might. Maybe I'm thinking about something else. I think this one works fine. Let me see. Where's my T-score chart? Does this work okay? Yeah, it should actually. Yeah, okay. What do you get when you look up in your T-score chart? So it's a one tail test, 0.005. Somebody's chatting at me, but hold on. Oh, where are my T-score? There they are. All right. Why would the T-score chart be preferable? All right. Why is the T-score chart kick so much ass for hypothesis tests? What piece of it makes it so cool for hypothesis tests?
The last one.
No.
It tells you the area and the tails.
Okay. What are the two main types of hypothesis tests we're gonna have? Not mean in percentage, but one tail, two tail, correct?
Mm-hmm.
Doesn't this break it down into one and two tail? So that's why it's preferable, unless the percentage is not on here. But one tail 0.005 is on here. So I was thinking, I think somewhere there's a problem I made that was 0.005 and two tails. And if I had 0.005 and two tails, could you use this chart? No, because nowhere does it talk about 0.005 and two tails, right? Are you guys understanding? Or more immediately, what if I said alpha was 0.07? Could you use this chart? What if I told you alpha is 0.07? It doesn't matter how many tails. Could you use this chart?
No.
No, because they don't freaking have 0.07 on here, right? So these are the only alpha values we've got. Okay. Where do I stop here? So I know I'm looking at this column. Where do I stop? Good. So 2.576. That should sound vaguely familiar, maybe. Okay. So this step is the same, right? This step is exactly the same for means, for percentages. It's the same step. So right here, this is 2.576. Does somebody know how to put this picture into words? So let me do this. Let me reinforce the same idea. I know there's like a level to hypothesis tests that there's a lot of detail, and you're like, oh crap, I got to remember this formula, I got to remember this idea, I got to remember this. Never forget the main idea behind the whole thing. The one that has no details to it. It's just the idea. Where does this think the sample should end up? It thinks the sample should end up in here. Yes? Right? It thinks it should be equal to or less than that. So equal to would be around this somewhere. You guys with me? Because of course, like we said, it could be a little bit different, and that wouldn't mean shit because it's a sample. So this guy thinks it should show up in here. So when is this guy going to seem to be correct if I find the sample up there? Isn't that beyond where the first guy thought it should be? Doesn't that make, just by itself, does that make sense? No? Again, all right. The hoe thinks that it equals 55 or is less than, correct? So doesn't it think that any sample should show up close to 5.5? Yes? Yes? Yes?
Yes.
If it thinks it is 55%, shouldn't any sample show up close? And really, a good question is, what's close? Well, we've defined what close is now, haven't we? Close means anywhere up to and including this. So if I find a sample whose z-score is out here, that is not close to this, then anybody who thought it should be close, that is evidence that they're wrong. That's why we call this the rejection region, because then we can reject the null hypothesis. It must have been, or that's evidence that it is wrong, because if it was right, it should have shown up in here. Maybe? So if somebody was like, I can make 10 free throws out of 20, right? If they made 9, am I going to give them shit? No. If they make 11, I'm definitely not going to give them shit because they made more than 10. You with me? But if they make 3, isn't that evidence that they're wrong? Big time evidence they're wrong, right? Are you guys not understanding? So it's all about how far away you get. So if one guy, who's the guy who always thinks it could equal that thing? Which of the two guys thinks it could, always has to think it could equal that thing? Which guy thinks that? Oh, by definition, right? That's how we set it up. That's the one that always has the equal sign. So when do I show when that one is wrong? When the sample I get is far away, it's in unusual territory. That would be evidence that the one who thought it was equal to this is wrong. So that's the idea behind this picture, and that's the idea behind the words I use. If I get a z-star, if I get a sample whose z-score is above this, then of course I could reject the null because he's the guy who thinks it equals this. And if I get way the shit out there, that looks like it don't equal that, right? That's like the guy who said, I think the average age in here is 20, and we take a sample and we get an average age of 70. Right? That seems like it's probably going to end up being evidence he was wrong. Obviously, we need more information, but okay. So if z-star is greater than that, we can reject the null and we can support the hop. Let me erase some of this other stuff from earlier so I got less craziness. All right. You guys okay out there? I know that some of you just want me to just tell you what to always do when you see the word this, then you do this. No, that's just not, especially in statistics, it's not going to happen. The more you understand the underlying idea, the more sense the math makes, the more sense the ideas make. Okay. I like what I just said. The more you understand the idea, the more sense the idea makes. That's next level shit. All right, sorry, just giving myself shit. So now that we've set up, what is this set up for us? What is part C kind of, does somebody remember the way I was talking about this before? What did that set up for us that I'm gonna compare in a minute? What exactly is this line in the sand here?
The rejection region.
Good, that's where the rejection region starts. So that's how far, at least that far is where my sample has to show up to be evidence that the null is wrong. Okay, so this is kind of like a benchmark. Let me say this. Who likes football? Anybody like football? All right. So what if you had a football team? Even if you don't like football, you know what football is, right? And I don't mean soccer, I'm sorry. For anybody who's in any other country besides America, I'm not talking about soccer. So say you had a football team and everybody on your football team is slow as shit, right? They're all really slow. Don't you want at least one fast person? So let's say you set up a race and wouldn't you set a benchmark? Wouldn't you say you have to get to the end of this in 6 seconds or better? Wouldn't you say that? Doesn't that sound like something you would say? I need somebody fast. So you have to get to the end of this race and I'm talking about, it's really short of it, 6 seconds or less. So I want somebody quick.
That's why they have you run the 40 in tryouts.
There you go. Exactly. Tryouts. Why do they do that? To kind of gauge your skill set. Do you need somebody who's fast? I need somebody who can throw hard. I need somebody that can hit hard. I need somebody, all this kind of shit, right? So for this instance, it's all about speed. So I set a benchmark, and then what's going to be evidence that you should be on the team if you get past the frickin' benchmark? So that's exactly what 2.576 is. It's my benchmark. And if that sample don't get past it, it's not evidence. You ain't going to be on my team. Go on my favorite sports team. Score a point. All right. So we've set up the benchmark about where our sample has to show up. So of course the next step is, where did our sample go? How far did it make it? Did it win the race? So can you guys tell me what's N again?
$996.
996. What's X? Number of successes.
594.
594. I like it. So then you can figure out, of course, I'm being really nice here, by the way. Don't expect this all the time. But you've done this before. You know how to calculate percentages. It's the part divided by the whole. So what's P hat going to be?
$1.677.
Whoa. So what's immediately disturbing about
I
that?
did that upside down.
Real quick. I'm sorry, Patrina, do not take this like I'm talking to you right now, okay? Just in general, because this happens a lot. I almost always get at least one, if not 5 people who put P hat as that, and then Q hat would be negative 0.67 or something crazy, because they just do 1 minus. Are you guys understanding? And they just keep going like nothing's wrong, but that should immediately stop you in your tracks. You cannot get more than 1. And again, I am not coming down on Patrina. She knew exactly what she did. I'm just trying to help everybody else out. This is a real easy mistake to make, to divide the wrong way. If it's greater than 1, that's crazy, right? Okay, so what's it really supposed to be?
0.566.
5. I got something different, or is it just me? Do I just
I got 0.5964.
Yeah, 596. I like it.
I got my 9s and 6s flipped. Sorry.
Oh yeah, I picked really evil numbers. That's partially my problem. All right, 9s and 6s and everything. By the way, if you misread a number, I might take points off for that one thing, and then if you did everything else correct, I won't take any more points off. Do you understand? Can you understand that if you get P hat wrong, everything else is going to be wrong, basically? So I take that into account. I grade you on concept. So if you do everything else right with the wrong number, you will still get most of the points. And now we just got to plug and chug. This is the formula that we created earlier, right? So now I got 0.596. What goes here? You already identified what it was.
0.55.
55.
Good, 0.55. This is always the number from the claim. That's the middle we're assuming. Divided by this mess. And be really careful. Don't put the hatted stuff in here. Put the unhatted stuff. Does that make... Like, what kind of math class are we talking about hatted things? Well, this one. I don't remember what this is. Let's see. Nita. What do we get? Neat stuff. So let me know if you get that answer. There's so much that can go wrong putting this in your calculator.
I got 2.918.
Okay. There's one possibility. Anybody get something different?
Same.
Same thing? Okay, that's what I got. So either we're all wrong or we're all right. So, okay. Can somebody now by itself? So go ahead. Sorry.
I did not get that. I got 2.875.
So I don't know. You're gonna have to help me with what kind of calculator you've got.
It's the same.
Okay.
So
and
maybe I just entered it in wrong.
shoot. Let's see if I can make this thing work. Dadgum you. There it is. What the heck?
Yeah, I tried to just do it all
Did you see that at all? There it is.
barely.
Is that better?
Yeah, I just,
So the top's got to be.
I think I entered it in like wrong.
I'd
Let
say-
me retry that.
I don't know why my lighting is always so bad. All right. 2000. Neat. I think you did not put parentheses around the top.
Yeah, that was it. I got it now.
Okay.
Thank you.
No, if anybody got negative 34, that means you did not put parentheses around the top. I don't know how you get 2000. You did some math.
No, I got 2.8.
Somebody in the chat.
Oh, okay. Sorry.
All right, now everybody help me out. What is it we just calculated? What is this thing? What is this thing? Anybody? What is it? I've got it right there.
Z star?
It's a z-score. It's a z-star. That is a z-score. And how many places do we take z-scores out to? Because I'm going to want you to find the p-value. And
4.
no, come on. How do I find the p-value?
Two.
P-value is just the area in the tail that your z-score makes.
Would be 2.
Huh? So 200%. That's neat. I don't know how you could find that area without using the appropriate piece of paper. So let me say this again. The p-value is just the area in the tail that your z-score makes, that your z-star makes. So all I'm asking you is, what's the area above 2.92? That's all I'm asking you. How do you find that?
Find the area below and minus it.
Good. Yeah. Look 2.92 up. That'll give you the area below. And then do 1 minus that to get the area above. I think I got those here. Did I stop sharing this? Yeah, I did. Okay. So 2.92. I'm getting 9982. So then the p-value is going to be 0.0018. Is that cool? Would you say that's a high probability, 0.0018? No, that's right. That is a remarkably small probability. That's about 0.2%. So why does that make sense? What do we know when we got 2.92? Did we make it? Did we show evidence that the null is wrong, or did we not make it to show evidence? Did we make it or not? 2.92. Did we make it, or did we not quite make it?
We made it.
We made it, because what was the number we had to beat? Wasn't it 2.576? We had to be at least that far away. And we got a sample that's so freaking far away from 55 That's evidence that the real percentage is higher than 55. So what do you think about the Chicago police guy that said it's at most 55? Considering we just found really good evidence that it's more than 55. What do you think about the guy who says it's at most 55? Does he seem like he's right, or does he seem like he's wrong?
He's wrong and biased.
Well, yeah, good point. But the claim by itself is wrong. It doesn't matter who made it, but in this case, you're probably right. You might have been a little biased. Maybe. All right. Of course, I'm a college professor. We're all evil. We think evil things, but all right. So right there, even before we found the p-value, we knew the answer to the question, didn't we? The answer was we reject the null. We support the alternate because we made it in here. We draw it in there. 2.92, we made it in here, right? We're way the hell out there. Okay. So that's the nice thing about this. There are a couple of things that are different, but the whole idea stays the same. The 5 steps are basically the same, right? That's, thank God. Okay. Let's see. So we reject the null. Yes. So right here, I can say reject the null, support the ha. So we know we did. We didn't fail because we made it in there. We showed evidence. We made the team. We went fast enough. So how am I going to word my conclusion? Which one was actually the claim?
That P is equal to or less than 0.55.
So the null, right? The null was the claim. Is that cool? If the null was the claim, I better use this language, not this language, because this one describes the claim. Is that understood? I always get students that are like, I think I can get the thing. I don't know if to say reject or support. I don't know what words you want me to use. Just talk about the claim. The claim was the null, so I want to use this language. Is that all right? You guys seem beat up, which is probably appropriate. 5th week of a summer stats course. So what is your conclusion?
Wait, but it would be that he's right because he said at least.
He did not say at least. Go back
Oh.
up and read it.
So would it just be we found sufficient evidence to reject the claim that
Good.
at most blah 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 blah.
We have found. So anytime you make it in there, we did it. We have found. Anytime you don't make it in there, you say we have not found because we didn't make it. So we have found sufficient evidence to reject the claim that plagiarize. That at most 55% of Chicagoans. Is anybody from Chicago? Is that how you say it? Chicagoan? I don't think it's Chicagonite. That doesn't sound right.
I thought it was just Chicago. But that's what
Chicago?
now.
Chicago? It sounds like a type of toboggan. Where's the toboggan? Well, I got a Chicagan. Sounds like fine. Comes with hot dogs. All right, sorry. Or it's a deep dish toboggan. 55%. All right. So we have found enough evidence to reject the claim that at most 55% of Chicago, I'm pretty sure it's Chicagoans. I have to look it up. I forgot what it is. Gotta read, plagiarize better. Have an unfavorable view of the local police. All right. These are approximating words. Have an unfavorable view of local police. Okay. Probably for good reason. All right, anyway. So I want you guys to do as much of this as you can. Is anybody still copying this down? I'm sorry. Is everybody good? So let's do this. Let's do this. You want to do like we did yesterday? So if we finish this problem and then I talk really quickly about type 1 and 2 errors, then we'll call it a day after that. Does that sound okay? Does anybody desperately need a break? Are you guys okay? If any one person needs a break, I'll take a break. Okay. I don't see anybody. I know somebody's going to say to my dean, he didn't give us any breaks, that jackass. All right. So you're going to sound just like that too. Go ahead and do as much as you can of this problem, and I'll start to catch up to you after a little bit. How many people do we have? Okay. All right, let's make sure we're starting off right. Did somebody figure out what the claim is?
I got P equals 0.845.
Yes. So that's the claim that the proportion of students is the same as that percentage of professors, blah, blah, blah. All right, keep going. Go ahead. So then, of course, since it has an equal sign, it goes here. What would the ha be in this case?
Does not equal.
Good. So how many tail test?
2.
Good, because not equal to could be more or less to show evidence for that. So it's going to be 2 tail test. Jeff. What is Q? Not a non. Don't give me any.
0.15.
Yeah, 0.155. Of course, this is what you got to check to see if it's normal enough. And whatever the hell those are. I don't know. Let's see.
For the first one, 280.54.
Okay. So that's at least 5. That's good.
And 51.46.
51. Let's see. Wait a minute. Whoa.
Oh, never mind. I
Or the-
put 332.
Oh, this is
Yeah.
so this is not quite right. Okay, so I think you put the wrong base number in. Or something. So what do you get for this one?
For the first one, I got 272.09. And the second one, I got 49.91.
All right. And do you see what happened, Andrea?
Yeah.
Okay. And what does that mean?
It's normal enough.
Normal enough. So we can use
Z-score.
Z-scores. So if it wasn't normal enough, what would we use?
You would stop.
Yeah, let's stop. Exactly. Unless it's in the homework or on the test or something, because probably you missed something.
Hey Jeff, so how do you know if it's 1 till or 2 till again?
It's always all right. So this guy will always set up where the evidence is, where the evidence would be. It always sets up the rejection regions. What would it take to show something is not equal to something else? Does it have to be greater? Does it have to be less? Could it be either greater or less to be not equal to? No, yes, maybe, no. How do you show something does not equal something else?
Has to be greater or less?
Greater or less. So it could either be up here or down there. That's why it's a two-tail. So when will it be a two-tail? Whenever this is not equal to.
Okay.
Because in the other cases, it's going to be less than, which is one direction, or more than, which is the other direction. So that would be one directional.
Got you.
Cool. Like it. Keep going, everybody. Here's my alpha. If you didn't see, there's alphas up there. Up here. This is did anyone find the Z-score that defines what unusual starts at?
1.645.
1.645?
I got that also.
Good. Let me see if this strikes a bell. If there's 10% out here, isn't there 90% inside? Isn't this like a 90% confidence interval then? If that doesn't make sense or anything, just forget I said it. But just that number definitely looks familiar to us, right? So if it's greater than 1645 or less than negative 1645, then it is far enough away from the middle to say the guy who thinks it's in the middle is wrong. That is the fundamental thing we're doing here, right? Believe it or not. It's far enough away from the middle, and the guy who thought it's in the middle is wrong. That's it. That's what it is. That's not good enough to say that on your work, but that's the idea. Okay, keep going. I don't know if anybody needs all this up here still. So he's asking in chat a question about the p-value. You can always find the p-value no matter where the star thing is. P-value just means the area in the tail or tails that your Z star makes. That's all it means. It doesn't care if it made it in the rejection region, outside of the rejection region. That doesn't matter anything. This one's a two-tailed test, so we have to be careful. What do you guys get for p hat?
0.876.
Good. So then I get 0.876 is our sample data minus 0.845 is the supposed middle divided by a bunch of shit. Let's see, 0.845, 0.155, 322. All right. And again, just a z-score is a distance in statistics. It is a distance. And the whole idea of this whole thing is, did my sample make it far enough away? Right? That's why it makes a ton of sense that I'm calculating z-scores to see how far away we made it. So does anybody get this z-score?
I got 1.54.
Cool. So let's find the p-value real quick. This is a two-tailed test, so we're gonna have to do something a little, like maybe a little bit strange. I don't know. Can somebody, real quick, can somebody tell me where alpha is in this picture? Where's alpha in this picture? Where is it?
Divided between the two tails.
Yes, the shaded stuff, right?
Yeah.
It's divided, so this by itself does not represent alpha. I have to double this to represent the full alpha, correct? So, can somebody just tell me, can you look this up? This should be semi-quick to do. Can you tell me what this area is above 1.54?
Point 0.0618.
0.6, yeah, 9382. The 1 minus that will be 0.01, oh, sorry, 0.618. But I have to double it because it's a two-tailed test. So the p-value will be twice this, 0.1236. That's the p-value. Is that small? Would you call 12.36% chance of something? Would you call that really small? No. Especially considering the threshold for our problem was 10%. So there's two ways to get the answer for this. We already know right here. What did this tell us already? Did we fail or did we make it? Based right here. Did we fail or did we make it? Right here, this guy. Did we fail or did we make it?
Failed.
We failed, exactly. We all suck. No, we did fine. We did this beautifully. It's just that the sample didn't quite. Do you see that? I mean, do you see the visual you can make? That's where the sample fell. Did it fall far enough away? Nope. It didn't make it in there. So then I fail to reject the null because I can't do this because I didn't make it in there. So right here I can say I fail to reject the null, which means I fail to support the ha.
So the first part of the problem, I think I was missing because it looks like we were trying to find area twice. The first part of the problem is trying to find the z-score you'd need to exceed in order to to support the ha. The second part was putting in all the information to see if that information actually fell outside of the z-score that you found.
So part C is how far away does your sample have to get? And then part D is how far away did our sample get? I mean, that makes so much sense. Here's the benchmark. What am I going to do next? Go run, right? See if you make it. So here's the benchmark setting up, and then here's the running. Did our sample make it far enough away? In this case, no. So we failed, right? Because the probability that we would get a sample where we got it is relatively high. It wasn't low enough to show evidence that this guy's wrong. So which one was our claim? Which one was our claim, the ho or the ha?
The hoe.
Okay. That's our claim, right? That's where our claim came from. So that's how I want to word my conclusion. I want to word my conclusion using this language, not that language. Not really. Why? I mean, what are you concerned about? So, I mean, remember, if you can't quite get the homework done tonight, it's fine. The due date is just to make as many of you and get as much as you can done so that tomorrow you're ready. And so that I have time to grade some of it like tomorrow morning. Does that make sense? If you have to, continue doing the homework tomorrow and then come into office hours early and get some more answers, more questions answered. Does that make sense? I mean, that's once the due date happens, you don't just kind of like throw it all to the side and say, well, it's too bad. No, I mean, you keep doing it. All right, good. Let me see. Wait a minute. Where am I? Oh yeah, okay. Did everybody get that idea? Is anybody still wondering how I know which word to use when I do the conclusion? Why did I use reject or why did I use support? How the hell can I tell? I mean, it's just what we just did. The claim is the null, so I'm going to use the language for the null. So fail translates into we have not found sufficient evidence. Goodness gravy. Not found sufficient evidence to reject the claim that nobody's going to say it. Plagiarize that the proportion of students who think this would be impressive is the same as professors. So I can't say that they are the same. You guys with me? You guys understand? I cannot say that they're the same. But I can't say that they're not the same. It drives me insane. Same thing as guilty, not guilty. Can we ever say somebody's innocent? No. We can just say we did not find enough evidence to find them guilty, which we call not guilty, which is not innocent. Or sorry, I don't know. I'm sorry if I'm making your head go. Okay, one last idea for today, and then we'll get out of here early again today. This is all icing on the cake for me, by the way, because I thought for sure I wasn't going to have any class at all. So you guys are like, that would have been fine, Jeff. Too bad, it happened. So last thing, real quick. I'm going to be real lazy. Just keep going with this. Hold on. There we go. Tell me this. Can somebody tell me there are exactly two things that can happen at the end of a hypothesis test? Does somebody feel like they can tell me what are the two things that could happen at the end of a hypothesis test? You can either
Reject or fail to reject.
that's it. Make it a more complete idea though. So one thing that could happen, so two outcomes possible. Oh my God, Jeff. I don't know if I could write normal. I don't even know what this is just it. Two outcomes possible for a hypothesis test. Reject the what?
No.
The null, right? Or fail to reject the null. Now listen, guys. Are we certain about our answer at the end? Are we ever certain about our answer at the end?
No.
There is always a chance that we are wrong. Just like real life, we have to play the odds. We have to think about the probabilities. Just like in real life, right? Oh, should I sign up for the 7 a.m. class? What's the probability that I'll make it up on time and I won't die in this class? I mean, right? Some of you guys, yes. Some of you guys, no. I would be a no on that. But all right, now, so if I reject the null, when would I be wrong? Because there's a chance I'm wrong. If I reject the null, when would I be wrong? When would it be wrong to reject what somebody says? When in reality, that person is when it would be wrong to reject what somebody says, when in reality that person is
Correct.
correct. There we go. So if the null is true and we reject it, wouldn't you call that an error? Wouldn't you call that like a mistake? Is it a mathematical mistake? No. We did all of our math right. We did all the math completely right. I really want you to understand this. But because statistics involves probabilities like real life does, there's always a chance that we're wrong. So even if we do all the math perfect and we picked a beautiful sample, oh, everything's like, wow, there's still a chance that we are wrong. Which is why, how does science work? If one team sees something, why can't I accept that yet? What do I want to have happen after one team does something? What do I want to have happen before I start to believe it? Anybody? Does anyone know how science works? If one team does something, like one team rejects the null, when would I start to believe it? When how does science work? So if one team does something, I'm not going to believe it until another team does the same thing. Does anyone ever duplication? What's the right way to say that?
Redundancy.
Not redundant.
Repetition.
Repetition, sure. I want to see the result happen again, right? I want to see verification that the first team didn't make a mistake somehow. Okay, maybe. So, all right. I don't know what the whole point was, but I would be wrong to reject the null if the null is true. So if the null is true. So this is one of the two types of error we can make. This is called a type 1 error, and it's rejecting a true null. Good Lord, Jeff. Don't worry, I'm going to come up with an example in a minute. So the second example, of course, just to cut to the chase, the type 2 error, when would it be wrong to reject, I'm sorry, get out of there. Why am I writing everything twice? I don't. When would it be wrong to fail to reject a no? If I fail to reject what somebody's saying, when is that the wrong thing to do? Somebody says something and I say, and I go, yeah, maybe so. I don't reject what he's saying. When is that wrong? When should I have rejected what he said? If what he said was
Incorrect.
incorrect, was false. So if I fail to reject a false null. Now I know this sounds technical. It really does. Fail to reject a false null. Holy shit. But all it's saying is, if the one guy said something false and you didn't call him out for it, then you made a mistake. And this first one says, if the guy says something true and you're like, you're full of shit, well, then you made a mistake. That's all it's saying, right? That's the types of error. So let's see these things in action, and then we'll call it a day, okay? Let's see. I'm going to clear this away. Is everybody ready? Okay, I don't hear anything. I'm going to hear something the second I do this. All right, so let's do something not mathematical. All right. What if I'm a medic? All right, I like this example. I always do this example. What if I'm a medic on the battlefield, right? I'm a doctor on the battlefield, and I'm going out to the field, and there's all these people laying down. What am I going to come up and test for? I come up to somebody who's laying on the ground, this body laying on the ground. What am I going to try to test to see if they are
Alive.
So this is kind of weird. So I'm trying to show evidence that they're alive, right? So I'm trying to show evidence that the person is alive. So what's the null hypothesis?
The person is dead.
Dead, yes. Now, let's talk about the types of error. What would the type Here's how I remember these, by the way. Type 1 error is the shorter phrase, reject a true. Type 2 is fail to reject a false. Holy shit. So type 1 error, reject a true null. So say the null is wrong when in reality the null is right. So we think what when in reality what? We think what when in reality what?
You think they're alive when they're dead.
Good. So I don't know how. Sorry. I have no idea what language I'm using here. All right, so reject a true. So the null is true. In reality, they're dead. They're dead, Jim. But we think, so we reject that. We think they're alive. So like I could maybe check the pulse with my thumb. Does anyone know it's bad? You know,
Skin is thicker on your thumb, so
Say
you
again?
can't feel the pulse.
Well, you actually can feel your own pulse. So you might incorrectly believe somebody's alive. You might feel a pulse, but it's not their pulse you're feeling. Or you might hold up a mirror on their nose and that's supposed to see the breath and you sort of think there's fog and there isn't. Are you guys with me? So there are ways we can think they're alive, but they're really dead. Why would that be bad? Why would that error be bad?
You could be wasting time on trying to
Good.
save other people that are alive.
Yeah, I'm wasting time. Okay. So what's the type? And again, I understand this is kind of a crappy, evil example, but too bad. So type 2 error, fail to reject a false null. So I always think, so we think that blank when in reality, blank. Okay, so the null is false. So what is the reality? They're what? If the null is false, they're alive. It's alive. But what do we think? Because we, of course, reject that. I mean, I'm sorry, we fail to reject that they're dead. Ugh. So what do we think? We think that they're dead. You see how they're almost the same thing? Just one is kind of the reverse of the other one. Okay. And why would this be bad? Because then we would pass them up. They're like, oh, thank God he's here. And then I move on. They're like, oh, shit. All right. So that's wrong. That's bad because I didn't spend any time on the person that I could maybe save. Okay. Does that help at all? Somebody had a question about the types of errors. So when they give you math stuff, like if they said the null is this and the H1 is this, well then in reality, the mean is at most 11, but we think the mean is more than 11. Do you see how that falls into place? It's the exact same setup, just with numbers then. It's the same idea. So you're going to see these types of errors. I think it's in section 9.2. Is that what you first? I can't remember. Okay. So again, these are errors that are outside of anything we can do about them. These are errors just because we don't know reality. We do the best we can with what we observe, and we can make mistakes. The math isn't to blame. It's just life. Okay. All right. So I was going to do a little more, but I think I'm just happy that I was able to do anything today. So I think that's, and the fact that we haven't had a break. So I think that's enough. Let me know if you have to hang out. I think somebody had something they wanted to ask after class. Let me know. Otherwise, you are free to go. And I didn't say anything about this, but of course the quizzes are graded. So if you haven't looked at those yet, take a look. The average was an 86. You understand what I'm saying? The average was 86. That doesn't mean everybody did. That means most People did pretty good. So let me know if you didn't do so hot. You can still make corrections. Who had questions? Anybody else? Anybody?
I have a question about 9.2, the number 11.
I have a question on 8.3 whenever, or 8.1 whenever.
Okay. And you said number 11 in 9.2?
Yes.
Okay.
So I said that the null is P equals 32,000.
Mu, right? It's a mean, so you wouldn't use P.
Okay.
Oh, I don't know. What is 9? All right, I don't understand. All the due dates show up in Canvas, so somebody's asked me about a due date. Let's see. 9/1 right here. 9/1, July 17th, and that is not today, so you got time on it. Let me see. So many chat. Oh, yeah, no worries, no worries. Oh, thank you. Somebody answered. Okay. Go ahead. Sorry.
Okay, so the null is equal to 32,000, and then the ha is it's not equal to 32,000.
Okay.
So I said type 1 is we believe the mean price of mid-sized cars is not 32,000 when in fact it is 32,000. Okay. I think the answer in the back said it differently, so I thought I was off, but no. Okay. Thank you.
I'm pretty sure it says it right, so take a look. But
Okay.
sometimes they just word things weird. Oh, either way, I mean, yeah, hang out. We'll see how many questions there are. How's everybody else?
I have a question on, oops, sorry.
Go ahead.
103, 8.1. I just don't know how to go about it. How many male students must you measure? Yeah.
That sounds weird. Let's see. 103. Oh, okay, so this is an example. So you want to know how big of a sample.
Mm-hmm.
We need a formula solved for n.
Okay.
That's when I get you that z squared business, right? Let's see.
Oh, I don't think I have that written down.
It's on that worksheet we did with the dolphins.
Oh, okay. Then I'll be able to find it. I'm sure once I get the formula, I'll be okay. I'm sure.
The z you gotta use is weird because this is 93% confidence, so it's not going to be on the t-square chart, right? Because it's 0.07.
Yeah.
You gotta do it the old-fashioned way.
What?
There's 93% inside, 7% inside. How much on that side?
Oh, okay.
Look that up. You'll get the negative.
Okay. I was like, what's the old-fashioned way? But okay. All right. I'm sure I can figure it out then. All right. Thank you.
All right. Who else? Patrina, you.
Yep. So I guess first question is, I know that you don't use Canvas to put together our grades, so the quiz grade hasn't been factored into the average grade.
I just
Okay.
finished grading them like before my internet decided to die.
Okay.
I was on the internet doing everything, and then right when class was supposed to start, it's like, no. It was awesome.
So I'm gonna go back to 7.1. I know we just finished the quiz, but I'm going back to do all my corrections.
Yeah.
And for 7.1, F, sorry, it was 65 F.
65. Okay. All right.
Yeah, it was the question about the interquartile range.
Sure.
I've just completely blanked out on that one.
All it is, so the range is high minus low, right?
Okay.
You can say it's from the low to the high. So the interquartile range is one step in. It's Q1 to Q3.
Okay.
So C in part E, you figured out Q1.
Yes.
Find the first quartile. Now I just got to find the third quartile, and you got part of it.
Okay, so it would just be from Q1 to Q3 for that one. For 68B, was it 68? Did I do the wrong question? Oh no, this is the right one. Okay. Find the probability. So I did X bar is greater than 5, or probability that X bar is greater than 5.
Good.
And then I graphed it, and then I was like, well, I probably need to find a z-score. So I did 5 minus 36, which is X bar minus mu.
Good.
Divided by 2.5.
Good.
And it gave me negative 9.4.
Yep. We know exactly what that means.
So then, and then I couldn't find that on the z-score chart, and so I wasn't sure what to do.
Yeah, we talked about this. So the chart says negative 3.5 and below. If you look at so the chart claims that's always 0.0001.
Oh, okay. Because I was like, that seems way too low. I didn't know. I thought I calculated it wrong.
Well, no. It is 5 is really far away from 36 if every step is 2.5 big, right? So that makes sense. But me, I would say if it's off the chart, especially if it gets down to freaking 9 or something crazy, that's approximately 0%.
Okay.
So other side, which is what this wants. It wants greater than, must be about 100%.
Okay.
Now, if you do what the chart says, it'll be 0.0001. So then the other side be 0.9999. Either way, I'll take it.
Okay. And then my last question for 7.1 was 69E.
A couple different ways to answer this. You can either calculate them, which isn't really what it's asking, but where should, in a normal curve, where should most samples show up?
In the middle.
Somewhere in the middle, close to the mean.
Right.
So which one of these ranges is closer to the mean?
The mean, let's see, the mean is 2000, so it would probably be the first one.
There you go.
So just because it's closer to the mean.
Yeah, why is it more likely? Because that's closer to the mean.
So there's no calculation for that part?
You can, like I said, some people are calculated probabilities, which is fantastic because you can always get more practice of that. But
okay, you don't actually need to for this question.
you don't have to. It just says, why is it? So as long as you can adequately explain why, then you've got the question. You don't have to do any work.
Okay. And then 7.2, it was, I think, 7.3, my mistake, 7.3. There's no 7.2. I think I redid that one completely.
Let me check in with Melody. What's going on, Melody?
Oh, I just had a question for section 9.4 and 46. And I think you must have gone over it when I didn't come in early. It was about if you're given both the standard deviation for the population and the standard deviation for the sample, why would you choose the population? Like sigma, like why would you choose sigma? And I know you're supposed to choose sigma, but I can't figure out how to explain it.
All right, so here it is. And I've said this a few times, but I've said a lot of things, so I understand how I can get mixed up. S, the main purpose of S is to estimate sigma. The main reason S is used is as an estimate for sigma.
Okay.
So if I know sigma, I would never use S. Because S's job is to be an estimate for sigma. But if I know sigma, why would I need an estimate for it? Right?
Okay.
Does that make sense? I mean, that's really all there is to it.
Thank you.
Is that all you had? I thought you had other questions.
No, that was it.
Okay. All right. Yesenia, what you got?
I'm doing quiz corrections right now for quiz 1. Like the last question. For 5A, I put discrete.
Yes. Okay.
but you like circled some words on, I don't know if it's like the way I worded it or.
You have to be a little more specific because the number I gave was not a whole number. Do you see what I mean? But of course it was an average. So I needed you to be more specific, discrete. What's the whole number? What has to be a whole number?
Like in the problem?
Yeah. Mm-hmm.
The number of pets.
Good. So that say that. So the number of pets has to be a whole number. So it must get values. So that's why I circled the can.
Oh, okay. Oh, the same as the other problem I had. Okay.
Okay. And then do you see what was wrong with part B? So it's never about, it can change because the number of kids that you have can change, can't it?
Yeah.
That doesn't make that suddenly continuous, right? Just because it can change. So the thing with continuous is at a certain instant in time, can you measure something more and more and more precisely? And it keeps meaning something more, so I can't measure the number of kids I have more and more precisely at any instant, right?
Right, yeah.
But I can measure more and more precisely how much my kids weigh, right?
Uh-huh.
Yeah, so this was about puppies' weight. So it's the idea of we can keep going decimal places out more and more and more precisely as far as I possibly can take it. It keeps making sense.
Wait, so I just worded it wrong, right?
So when you said measured more and more precisely, it's like all right, I only took a point off because you basically got the idea, but you got to be careful because if I look out and I say there's about 12 sheep over there, if I get closer, can't I count them more precisely? Maybe I missed one or
yeah.
Does that make sense? So saying that you count more and more, you can measure more and more precisely isn't good enough. It's the fact that you can go out as many decimal places as you do. It doesn't have to just be whole numbers, or it doesn't just have to be certain kind of numbers. That's discrete. Continuous means you can fill in all the gaps between all the possible numbers. You can use any value between numbers. So I only took a point out because you basically got the idea, but really get at why it was continuous.
Okay.
How's everybody else? Was that everything you had? What's up, Ann?
Can I ask just one more? So section 9.2, number 18. So the null is the sunken ship does not contain buried treasure. So type 1 would be, we believe the sunken ship contains buried treasure, but it does not actually contain buried treasure.
Yeah, this one's E because the null has the word not in it, right? So I'm gonna have to, so I had to look it up to make sure I was remembering correctly. So say it one more time. The type 1 error is we believe
the sunken ship contains buried treasure, but it does not contain buried treasure.
Good. That's why I always start with the in reality. Because if you're like rejected true, okay, the reality is whatever HO says is true. So that's why it's easier to start there. And then you say, we think the opposite of that. And that's why we're wrong. That's how I kind of construct those errors, yeah.
Thank you, I appreciate it.
Sure. It's my job. You guys okay? What's up?
I just had a question in the last two of 7.3. I guess I'd been going, everything was normal up until that point. Question 96, 7.3 is the probability that X is between 85 and 125.
Okay.
And since the sample size is 20 and it didn't state that it was normal, I wonder what to do then.
The thing with IQ scores, I can't remember if either they have a problem in here, but IQ scores are known, or IQ scores, number one, are insane. They're just debunked. But number two, they are created to be normal.
Okay, so we just, because specifically stated that it's an IQ score, we can assume that it's normal?
Yeah, we know it's normal. Yeah. They're kind of forced to be normal. Yeah.
All right, that fixes that. And then, oh yeah, 97, I think it might be the same answer, but I got a Z-score of 22.5.
Because you used the wrong standard deviation.
Okay.
So this is a thing I've talked about a few times, but like the expected number of rejected coins. So if I knew the probability that one coin could be rejected, I could then multiply that by 280 and see the expected number of coins.
Wait, say that again.
Remember, expected number means the mean?
Yep.
And the mean is n times p.
Mm-hmm.
So if I figure out the probability that a coin is rejected, I can then multiply it by n, which is 280, to see the number that's rejected. So what I'm trying to tell you is, I'm not taking a sample and asking you about the sample mean. Nowhere in this problem does it say that.
Okay.
So this is not one where I change the standard deviation. You use the original standard deviation. And the reason they put this here, and this is appropriately number 97, this is the hardest problem in the whole thing, is because it's not a chapter 7 problem.
Okay.
I want you to realize, okay, we taught you this new thing, but do you really understand when to use it? So you only use it when I take a sample and I ask a question about the probability sample mean does something. That is not what this does.
So this is a chapter 6 question?
It's in chapter 7, right?
Mhm.
Yeah, 7. Is that where we are? 7, yeah.
Mm-hmm.
It's in chapter 7, but it does not use chapter 7's ideas.
Okay.
Why did they put it here? Because they want to make sure you remember what's the difference between when do I change the standard deviation and when do I not.
Okay. I think I got
This
it.
one is definitely evil for that reason.
So you just take that and then you divide it by the regular standard deviation?
To find, yeah, you got to make 2 z-scores, right?
Mm-hmm.
And it'll be rejected if it's outside, right?
Right.
On
But
either
that's
side.
normal stuff. Yeah.
Say again?
But that's just regular chapter 6 stuff.
That
Right.
is.
Okay, cool.
And the one little thing about this is they should have said it was normal and they didn't, but we have to assume it's normal. Yeah. So
Yeah.
I almost like this problem, but this book every now and again forgets to say things like that.
It gives us n is equal to 280 though.
Again,
So
it's not a central limit theorem problem. So central limit theorem doesn't save my ass. We're talking about one coin. So the sample size is 1. Nothing saves my ass. So
right. So then you assume it's normal.
you have to assume it's normal. Yeah.
So then what does the 280 mean?
280 is the n that you're going to multiply by the probability you find. So what you're going to do, now watch this, watch. If I somehow knew, stay with me. If I somehow knew that the probability a coin was rejected out here, if I knew that probability was 10%,
Mm-hmm.
and so how many would I expect to be rejected out of 280?
10%.
Say again?
10%.
Of 280, right? So I would take 10% of 280, that's n times p, and I get 28.
Yep.
But that's not the right probability. You have to find the probability that one coin, and that's a terrible picture, but that's even better, Jeff. You got to find these probabilities. You got to make those into z-scores. Get this area, and add them.
Okay. So the question should have stated that it was normal. It's not normal because n is equal to 280. It's normal
Because
because
we have to assume it's normal, but yeah.
Okay.
It could have said they're normal, and again, it's, they made an almost good problem here.
okay. And then just uses these scores and it is normally. So the 280, what does the 280 serve? The purpose of them telling us 280?
Well, you just used it. If you knew the probability was 10%, how many coins would you expect to be rejected? 10% times 280, right?
Oh, right. Yep.
So
They didn't
whatever you
give
get,
10% anywhere. Oh, okay.
I just made it up.
Yep.
Right? I'm like, let's pretend like it's 10%. And
So
now
now
you
we find the percentage, multiply that by 280, and that should tell us our approximate.
that's the expected number to be rejected. So you got to find the right probability.
Okay.
Yep.
I think I got it. Thank you.
You're welcome. Yesenia, you okay?
Yeah. I